Hi, I'm Dewey Benson. I'm with a company called Energy Quest Technologies. We're out at Chandler, Arizona, and today we're out here at Pima Air Museum, and we are running some tests on a Boeing 737-300. And what we are doing is injecting ozone-enriched air into the aircraft to prove that you can sterilize the aircraft in about an hour. And we've been working with the University of Arizona with microbiologists from U of A to determine whether or not our process is effective. So we've been out here for a week developing our procedures, and then the last 2 days we've actually been testing with viruses on board the aircraft to determine whether or not this procedure would actually destroy the virus in an effective manner. The air conditioning external ports on the aircraft to push ozone-enriched air into the airplane, and so we actually use the air conditioning distribution system on the airplane to distribute that ozone-enriched air throughout the aircraft. We are trying to get the ozone concentrations up in the airplane up to a level that will be effective in a short amount of time so that the whole process fits within the operational tempo of an airline or the Air Force itself.
Hi, I'm Emily Cooksey, a PhD student at the University of Arizona School of Public Health, and I'm working in the Community Environment and Policy Department. And so we are out here looking at the viral efficiency of ozone on planes, hopefully to be used to remove coronavirus and other bacteria and viruses that could be on plane surfaces. And testing the tray tables at both an open and a closed position to see if the ozone is able to penetrate the closed position. And we are also pulling out rods connected with the ducts to see at different time intervals how effective the ozone is on the virus removal. In the lab, it takes us about 24 hours to process these samples, and we are using a plaque assay method, which allows us to count the number of plaque forming units on a plate that is from our samples that we swabbed.
So one of the interesting things, and one of the questions, of course, is whether or not the ozone is safe on board the aircraft. So the first thing is we run ozone concentrations that are higher than what the OSHA limits are. You can't have any people or animals on board the aircraft while we're doing that. But the objective, of course, is to keep the process short enough so that is not a problem. The second question is, does the ozone damage the aircraft in any way? And an interesting side note to that is that aircraft fly through high concentrations of ozone typically every day. Any aircraft flying above about 40,000 feet will encounter high levels of ozone because of they're flying close to the ozone layer in the atmosphere. A typical aircraft might encounter ozone levels as high as 10 times the OSHA limits. And in fact, just about every aircraft, every commercial aircraft, has ozone converters on board that take the air that's coming into the aircraft from outside and reduce the ozone concentration levels down to a safe level for the passengers. So it's not for the aircraft's benefit, it's actually for the passengers' benefit. The aircraft itself is used to the ozone levels, and we don't expect to see any kind of degradation due to the concentrations or levels of ozone that we'll encounter in the airplane. We have sensors located throughout the aircraft, fore, mid, and aft sections of the aircraft to monitor things like temperature, humidity, and ozone levels. And we take measurements throughout the process to see and really determine what set of parameters works the best and most efficiently to make this whole process quick turnaround. I want to thank Pima Air Museum especially for letting us use their aircraft. It's been a pleasure indeed working with these guys. They're just great, and I hope we get a chance to do some more with them in the future.